Another question. Figure 1.1 shows a speed time graph. So these are the speed time graphs. The previous question. Abdullah, you can use a mic. Which question? This one?
Yes, sir.
In this question, this is, keep in mind, this is a distance time graph. Okay. If you have a distance time graph, like if I say you have a distance time graph, how you show the speed is decreasing or deceleration for a distance time graph? Can you sketch a distance time graph on this grid, this side, not on the main grid, which I drew? A distance time graph for decreasing speed, which is also called deceleration. This is a distance time graph, Abdullah. A distance time graph, not a speed time graph. Yeah, distance time graph. So when you draw a decreasing speed or deceleration, which is also called deceleration, this is the shape of the graph. So what they mention here, they mention when time is equals to 35 seconds, the aeroplane stopped decelerating. So till 35 seconds it was decelerating, and after 35 it moved with a constant speed. So how we draw a deceleration from 0 to 35? Can you sketch now on the grid the deceleration part from 0 to 35? Yeah, that's right. This is showing deceleration. And then they mention it moved with a constant speed for 15 seconds. So I will draw a straight line. Is it clear now?
Yes, sir.
Okay. Because it's a distance time graph, so you should keep in mind what will be the shape when it's a distance time graph and a speed time graph. What you was drawing was a speed time graph for deceleration. Okay, another question. Figure 1.1 shows the speed time graph of a person on a journey. So this is a speed time graph for a person, and the speed is given in kilometer per hour and time is given in minutes. For the whole journey, calculate the distance. So basically what happened, a person move with, they already shade the region for you. So for your assistant, they already give you the shaded region. The journey took 74 minutes. On the journey, he walked and then wait for a bus. Then he travel by bus. Then he get off the bus and wait for 2 minutes. Then he walks again and his journey took 74 minutes. So that's the total duration of his journey. For the whole journey, calculate the distance. So how we can calculate the distance? Distance travel is equals to area under the graph. So they already shade the region, but keep one thing in mind here, the speed is given in kilometer per hour and time is in minutes. So whenever we are substituting the time, this time should be in hours as well. So when we calculate from a speed time graph, if we want to calculate a distance, the distance table is equals to area under the graph. So, and all of them are making rectangles, so we'll use length into width. Now, what about the first rectangle? What is the length of this rectangle? It is from 0 to 20, but that is given in minutes. Because if speed is in kilometer per hour, time should be in hour. If speed is in meter per second, the time should be in minutes. In the previous, all the questions, I will show you all the grids. You can see speed was in meter per second, time was in second. That's why we were not converting the time. Same thing here. Speed was in meter per second, time was in second. That's why we did not convert the time into hours. Here also speed is in meter per second, time is in second. Again, we did not convert the time. But in this example, in this question, what actually happened, the time is given in minutes, where speed is given in kilometer per hour. Both should be in same unit. Like if speed is in meter per kilometer per hour, the time should be in hour. If speed is in meter per second, then time should be in seconds. So if the same question was there and speed was given in meter per second, then I should convert time into second. Now to calculate the distance travel, which is area under the graph, so it is starting from 0 and ending at 20. So what is the time? The time is 20 minutes. But we have to convert the 20 minutes into hour. So how I'll convert minutes into hours? What I will do to convert minutes into hours? So we'll divide by 60. So what I will do, I will divide by 60. So 20 divided by 60, what's the answer? 0.2. 20 divided by 60. It's Yeah, it's 20 divided by 60. 0.33. So this time interval is equals to 0.33. So this is equals to 0.33 hours. And what about the height of this? That is equals to 5. So what will be the area of this part? It will be 5 multiplied by 0.33. So what is 5 multiplied by 0.33? So 5 multiplied by 0.33, that's equal to 1.65. So 1.65, and because speed is in kilometers, so we'll get this answer in kilometer. But that's not the final answer, because we need the total distance traveled by a person. So we have to calculate the total. What about the second part? It is starting from 30 minutes and ending till 50. So the total is 20, again 20 minutes, and it is a recurring decimal. So instead of, it will be 0. Again 0.33. And what about the height? The height is equals to 40. So length multiplied by width. So 40 multiplied by 0.33. So 40 multiplied by 0.33. This will be 13.2 kilometer. And the last one, it is 52, starting at 52 and ending at 74. So 52 minus 74, or that will give us 22 minutes. So the last interval is 22 minutes. Again, we have to convert. So we have to divide by 60. So 22 divided by 60, which is equals to 0.366. And the height here is, after 5 it's 6. So it will be 6 multiplied by 0.366. So 6 multiplied by 0.366 times 6 equal to 2.2 kilometer. So when we calculate the total distance, that will be the total area of the graph. So 1.65 plus 13.2 plus 2.2, which is equals to 17.05 kilometer, or we can use a 3 significant figure. So we can write 17 kilo or 17.0 kilometer. Is it clear? The distance traveled by this. Is it clear to everyone? The area under the graph is giving us the distance traveled. The next part, they're asking the average speed. So what is the average speed? Average speed is the total distance divided by total time. The second part, we need an average speed. So average speed, that is equals to total distance divided by total time. So the total distance, as we already calculated, the total distance is 17 kilometers. But what about total time to complete the journey? That's equal to 74 minutes. But because speed, the unit of speed can be in kilometer per hour or it can be meter per second. So if we are calculating in kilometer per hour, so time should be in hours. So we have to convert these 74 minutes into hours. So 74 divided by 60, that will be 1.23. So 1.233, recurring decimal is there again. So when you divide this, what's the final answer? 17 divided by 1.233. 17 divided by 1.233. What's the final answer? The average, that will give us the average speed. So 13.78 or 13 point, because the final answer is 13.78. So 13.78 kilometer per hour. If you round off, because the number is bigger than 5, so it will come out as 13.8 kilometer per hour. So that is the answer for the average speed. Is it clear, this part? That using area under the graph, we calculated the distance traveled, and using the total distance divided by total time, we calculated the average speed of this journey. Then another, like more examples related to the speed time graph. I'll share another file with you, just a minute. Okay, so this is another file related to graphs and motion, and the answers are also given. So the first one, a solid plastic sphere fall towards the earth, so it is moving towards the earth. Figure 1.1 is a speed time graph of the fall up to a point where the sphere hits the earth. So this is a speed time graph. Describe in detail the motion of a sphere shown in the graph. So how we explain the motion? It's better you divide the question into parts. So one is from P to Q, then it is from Q to R, and then it is from R, S, and T. This part. So first, what is happening from P to Q? And keep in mind, it's a speed time graph, so we use the term acceleration. So from P to Q, what is happening? It's a constant speed, constant acceleration, deceleration. Yeah, it is accelerating and it is having a constant acceleration. So better use the term whether acceleration is changing. So it is constant acceleration. What is happening from Q to R? From position Q to position R, what is happening? Yeah, it is accelerating, but what happened to acceleration? That's true, it is accelerating, but what happened to acceleration? Is it increasing, decreasing? It's a speed time graph and the slope is decreasing. Speed time graph. And it is the curve, the angle is decreasing. So when speed time graph, the slope decreases. So what we say the acceleration is decreasing. So the first part, it was a constant acceleration. The second part, acceleration is decreasing. If it was an increasing acceleration, then what will be the shape of the graph? So for a speed time graph, this shape represents increasing acceleration. And the other part, this shape is representing decreasing acceleration. Then it is a horizontal line from R, S and T. So what is happening from R to S to T? It's a horizontal line. What is constant? Speed is constant or acceleration is constant? So it's a constant speed. Yeah, that's right. A constant speed. Or we can say zero acceleration. Or there is no acceleration. So this is the answer for this question, that how we explain the motion of a sphere by using a speed time graph. Okay, a question in which we have to complete a graph. In the question they mention a bus travel from one bus stop to the next. The journey has three different parts or points, and stated in order. First, what happened? It was a uniform acceleration from zero, from rest for 8 seconds. And then it is a uniform speed for 12 seconds. And then it is a non-uniform deceleration or not a constant deceleration for 5 seconds. What we have to do, we have to complete the graph on a figure. The question is on a figure, complete a graph to show the first two parts. So for 8 seconds, here each box is two boxes representing 1. So this one is 6, 7 and 8. So here is 8. Till what speed it will accelerate, that is not mentioned, but we can work out. How we can work out? Because they mention in a second part, the third part is already done. Like this is the third part which already they completed for us. We have to complete the first two parts. They already mentioned in a second part it was moving with a uniform speed. Uniform means constant speed. So after 8 seconds, it moved with a constant speed till 20 seconds. So it means it will be a horizontal line from 8 second to 20 seconds. It will be a horizontal line which shows that is a constant speed. And the first part, it was a uniform acceleration. Uniform acceleration means constant acceleration. So how we represent a constant acceleration? We represent by a straight line. So this represent it was having a constant acceleration. So this is part 1, part 2, and part 3 is already done for us. Is it clear? Is it clear, this part? Then use the graph to estimate a distance traveled by the bus from 20 seconds to 25 seconds. So we have to calculate a distance traveled from 20 to 25. So only this part we have to estimate as I mentioned. So what shape it appear? It is not accurate triangle, but it appear to be a triangle. But not accurate triangle, exact triangle. So what we will do, we'll find the area of the triangle which is half base into height. And we don't have to calculate the area for the whole journey because it only mentioned use the graph to estimate the distance the bus travel from 20 to 25 seconds. So you can use area under the graph for 20 to 25 seconds and your answer will be in the range for 24 to 28. I'm leaving some of the parts for you so that when you will solve this worksheet, you will, for first 8 seconds it was accelerating and then move with a constant speed and deceleration. And we only need the distance of this part. So we'll use the formula and calculate the distance traveled by the object from 20 to 25 seconds. In question 3, the car starts from rest and complete one lap of the track in 10 seconds. Like there's a race. So this is the say position of the car. So this car completes the lap, one complete rotation, one complete lap. And how much time it took? It took 10 seconds to complete the lap. Its motion is shown graphically in figure 1.2. So the speed time graph, speed is in centimeter per second and time is in second. So speed time graph is shown for the motion of a car. Describe the motion of a car from 3 seconds to 10 seconds. So from 3 seconds to 10 seconds, what is happening to the car? How you explain the motion of a car from 3 seconds to 10 seconds? So you can say it is moving with a not constant acceleration, constant speed and no acceleration. So this car is moving at a constant speed and it does not have any acceleration. And it's of 1 mark, so you just mention constant speed, you will get that mark. Use the figure 1.2 to calculate the circumference of a track. So basically what will be the circumference of the track? The distance traveled by the car is equals to circumference of a track. Like this was a track. So how much distance traveled by the car in one lap? Say car starts from here, start the rate from this point and finish. So the distance traveled by the car is equals to circumference. And how we can find the distance traveled by the car? That is equals to area under the graph. So what you have to do, you just have to consider or calculate the area under the graph. So you can divide this into two parts. You can have a triangle and you can have a rectangle. This is one way. Or you can completely take this as a trapezium in which you have two parallel sides. This is the first parallel side. This is the second side. And the difference between them is equals to h. So difference between them is 25. This one starting from 3 and ending at 10. So it is 7. B is starting from 0 and ending at 10. So that is 10. So we will simply use area under the graph or area of the trapezium to get the distance traveled by this car. So it will be A plus B multiplied by h divided by 2. So it will be 7 plus 10, 17 multiplied by 25 and divided by 2. So 17 into 25 divided by 2, what's the answer? What will be the answer when you multiply 17 into 25 divided by 2? 212.5. And 212.5, and what will be the unit of this distance? I told you that if speed is given in centimeter per second, so this answer is in centimeter. If the same was given in kilometer per hour, this answer will be in kilometers. Is it clear? Second part. The second part of this question, we need a circumference of a track. Circumference of a track, because a car is moving on the track, so circumference is the distance when we move on the surface. So the distance traveled by the car is equal to the circumference of this track. Abdullah, 17 multiplied by 25, and then you have to divide by 2 as well. So when you divide by 2, it will come out as 212.5. Then the next part, calculate the increase in speed per second. What is the meaning of increase in speed per second? So basically speed divided by time or velocity divided by time, what it gives? It gives acceleration. So sometime they change the wording, but instead of simply saying calculate acceleration, they said increase in speed per second. So what is this term, increase in speed per second? Actually it means acceleration. From 0 to 3 seconds we have to calculate acceleration, and it's a straight line graph. So when it's a straight line graph and we are calculating an acceleration, so we can use a formula in which final velocity minus initial divided by time. It is starting from 0, so initial is 0, the final is 25, and the time interval, that's equal to 3 seconds. Here we don't have to convert time because the speed is in meter per second and time is in second. So we'll get the same result. So it will be 25 minus 0 divided by 3. So 25 minus 0 is 25 and 25 divided by 3. So 8.33. Now what will be the unit? Because if speed is in meter per second, then acceleration will be meter per second square. But if speed is in centimeter per second, So acceleration will be centimeter per second square, because the distance was given in centimeter and speed is also in centimeter. So our final answer will be 8.33 centimeter per second square. Moving on to the next question. Figure 3.1 shows a skier descending a hillside. Figure 3 shows a speed time graph of his motion. How can you tell that the acceleration is constant for during the 8 seconds? So how you can say that he's moving with a constant acceleration? So there's a term which we normally use when the acceleration is constant, because the slope or the gradient of line does not change, or we can say it is a straight line with constant gradient or slope or angle. That is why the acceleration is constant, because for a speed time graph the gradient, the slope represent acceleration. So you can mention that slope is constant, or slope is not changing, or gradient of a line is not changing, or angle of the line is not changing. You can use any term. The scientific term, normally we use the term slope or gradient when we represent acceleration from speed time graph. Then calculate the acceleration of a skier. How we can calculate acceleration? It's a straight line graph. So again, we'll use a formula which is v minus u over t. So it is starting from rest. So initial velocity is 0, final is 6, and the time interval is 8. So 6 minus 0 divided by 8, or it will be 6 divided by 8. So 6 divided by 8, that will be equal to 0.75 meter per second square. Is it clear, this question? Figure 1.1 shows a speed time graph for car traveling along a straight road. So car is moving along a straight road, and this is a speed time graph. The graph shows how the speed of the car changes from A to B, from B to C, and from C to D. Describe what happened to the speed of a car from A to B. From A to B, what is happening to speed of a car? Or what is happening to a car? Accelerating, constant acceleration, constant deceleration, zero acceleration, or acceleration increasing, decreasing. What we can say from A to B? From A to B. Yeah, that's right. Constant deceleration. Why deceleration? Because original speed at A it was 25, and at B it is smaller value. So it is not accelerating, basically it is decelerating, or constant deceleration. What is happening from B to C? From B to C, it's a horizontal line. So it shows it is a constant speed or no acceleration. And what is happening from C to D? From C to D. So it is having a constant acceleration. So first was constant deceleration, then constant speed, and then constant acceleration. Then calculate a distance travel between the start and the end of the. Yes, Heather, any question? Calculate a distance traveled from start of the town to the end of the town. So this is a point. At point B, the town started, and town C, at point C, the car leaves the town. So we want to calculate a distance from B to C. So speed time graph, when we are calculating a distance, so we take area under the graph. So area under the graph, this is 18. When it entered the town, it is time was 18, and when it leaves the town, it is 42. So the time interval from start to the end, so it will be 42 minus 18 equal to 24. And the distance, the height, this one, each box is representing 0.5. So 10.5, 11, 11.5, 12, 12.5, 13. So this is 13. So the height is 13. So 24 multiplied by 13. What's the answer for the distance travel? 24 times 13. 312. So the distance travel by this car from start of the town till the end of the town, 312. And what will be the unit? Because speed is in meter per second, so it will be in meter. If speed was in kilometer per hour, then it will be in kilometer. Is it clear, this question, that how we calculate distance traveled by the car from start and end of the town? So these are some questions related to speed time and distance time graph. In the next week, we will start a new topic, as we are completed this topic 2 as well, which is about the motion. And we discussed speed, velocity, acceleration, speed time, distance time graphs, and different calculations from the graph. Any question related to the class today? So I'll end the session and share this recording with you.